to projects. In this video, we are going to discuss about the project which is object detection using FasterRCNN, YoloV7 and YoloV8. So first, let's understand what is the project about. So what is object detection? Object detection is like teaching a computer to recognize and locate objects in the pictures or videos. So imagine showing a computer a photo of a busy street and asking to find and label all the cars, pedestrians, and traffic signs in this. So this object detection algorithms, they are designed to do just that. They analyze the image, figure out what objects are in it, and then draw bounding boxes around each one saying what it is, whether it is a car or a person. This is super useful for things like security cameras, self driving cars, and robots because they need to understand what is around them in order to make decisions and take actions. So, traditional object detection models that are histogram of oriented gradients, that is HOG, Viola Jones, and Haar cascades, they often relied on manually crafted features and sliding window techniques. But the problem is they work well with the simpler scenarios. And when it comes to the complex scenes, they struggle and it results in the lower accuracy. So, to overcome all these limitations, in this project, we are stepping out to more advanced solutions. So we tried out three advanced object detection models, that is faster RCNN, YoloV7 and YoloV8. So these are the object detection models of deep learning. So coming to this YoloV7 is known for its precision and reliability. And it is bit like a detective. It looks at the image into two stages, finding potential areas where objects might be, that is where object is located, and then examines those areas more closely to identify the objects accurately. So moving on to this YOLO V7 and V8, these are the variations of the model called YOLO, which stands for You Only Look Once. And these models are designed to be super fast, efficient, and ideal for real-time object detection tasks. So all the YOLO models, they are real-time object detection models. And they take a different approach by looking at the entire image all at once and quickly pinpoints where the objects are located. And we evaluated all these three models, that is faster RCN and YOLO V7 and YOLO V8 using mean average precision, and recall. So by using these three metrics and evaluating the models, it will help us to see how well each model performs in terms of accuracy and we'll be testing them on images, comparing how they do in terms of spotting objects, that is identifying objects accurately and quick. Moving on, we already told you that we are using faster RCNN, YOLO V7 and YOLO V8 for object detection. We'll be using all of these three individually for detecting objects. So as a front end, we have integrated Flask for developing the web application. So we integrated Flask framework for developing the web application. So what is this Flask? Flask is like a lightweight web framework for creating websites using Python. So we used this in our project to make a website where people can interact with our object detection system. And with this Flask, we can set up features like sign up and sign in using a simpler database called SQLite 3. So we used SQLite 3 for the database for storing the sign up and sign in credentials. So users can upload images on the website for analysis. And Flask, it helps to manage all these interactions by directing them to the right parts of a project, that is backend of a project, where the images will be pre-processed and predictions will be made. This way users can easily use the project through web browser. So to implement this project, we need software and hardware requirements. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And moving on to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. We understood what is the project about. Let's execute them. So to execute the project, we need to open the code folder which contains source code files. So these are the source code files in the code folder of a project. So let's understand each of them. How will they be used in the project? So first, let's discuss about the data folder. So we have data in the data folder. Here data is split into two subfolders. One is train and the other one is valid. In train, we have two more subfolders. One is images and the other one is labels. In image folder, we have images, and in labels folder, we have label files. So coming to image folder here, we can observe that there are 5,805 images. We'll be using all of these images to train the FasterRCNN model. Get back. Coming to the labels folder. Here in this folder, we have files containing annotations or label files for objects in the corresponding images. So here each label file, it corresponds to an image file in the image folder. For example, this first image file, that is label file, it corresponds to the first image file in the image folder. Similarly, the second label file, it corresponds to second image in the image folder. And that second label file, it provides the detail about object locations and classes within the image. So for all these 5,805 images, we have 5,805 label files. So here we can observe there are 5,805 label files which provides details about object locations and classes within all the 5,805 images. So we will see a file for sample. So I'm opening the first file. Here, each line it specifies a detected object. So here there are 17 lines, so 17 objects are detected. In each line, it specifies object class index and followed by its bounding box coordinates. So here we can observe that there are different types of object class index. 0 refers to one type of object, 3 refers to one type of object, 4 is another kind of object, 2 is some other kind of object. So coming to the bounding box coordinates, this is the x limit, this is the y limit, and this is the height, and this is the width. Similarly, we will have for all other label files also. So now close this, get back. We have a validation folder also, two subfolders, images and labels. Here in images, we have 549 images and we have 549 label files for all the 549 images. So now get back. We'll be using train folder to train the model and validation folder to evaluate the model. That is how well the model is performing. Now get back. Similarly, we have images in YoloV7 and YoloV8 folders also. So these folders contain same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized and ensures that each YOLO version receives the correct annotation and it needs to be functioned properly. So moving on to the static folder, this folder contains files related to project styling and interactivity. These include CSS, JavaScript, and Bootstrap files. Moving on to the templates folder, here lies all the HTML pages utilized in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website which provides the structure and layout for displaying content to the users. Here in the sample folder, we have test cases. We'll be using all of these images for detecting objects in the front end. Now get back. This is app.py file. This Python file encompasses front-end logic of the project, and it handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. Here we have model folder. In this folder, we have files containing information about the algorithms used in the project, and these are loaded into the project code during runtime. And here we have object.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. Now we understood all the files. Let's execute the project. So we have to copy the path of the code folder from the address bar of the file explorer. So copy the path. Now open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. Here we can observe that current directory is changed to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which will be the local host and the port unless configured differently. So this is the local host and this is the port. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here and now click on enter. This is the web page of the project, which is displayed in the browser, and this web page is developed using Flask framework. So first click on sign up link and enter all the registration details if we are registering newly. I already registered and I have an account in it, so I'll directly log in. Click on login. Give the credentials here, which are username and the password to log in, and now click on login. We have logged in successfully and we are redirected to detection. So here we can see a choose file button. Click on that for uploading the images for detecting the objects. And coming to the detection part, if you want detection using YoloV7, select the option YoloV7. And if you want object detection using YoloV8, select the option YoloV8. Similarly, FasterRCNN. So for every individual image, we'll be doing object detection for all the three models, using all the three models. So let's upload the images. Click on choose file to upload images. So we'll upload the first image. Click on open. We can observe that image is loaded. Now it's time for selecting the model. So first we'll select YoloV7. Click on upload. Here we can observe that a person is detected with the purple color bounding box around the person. Application has drawn purple color bounding box around the person and labeled as person and given detection score as 0.85. Detection score is nothing but it is the confidence level that how accurate the detection is. So it is 85% accurate. Detection is 85% accurate. So for the same image, we'll do object detection using the other models, get back. Let the image be same. Now we will try using YoloV8 model. Here we can observe that same person is detected and a red color bounding box is drawn around him with the 0.89 detection score. We can observe that YoloV7 has 85% accuracy rate and YoloV8 has 89% detection rate. We can observe that YoloV8 is performing well than YoloV7. So let's upload one more image. Before uploading one more image, we did not try the image with the FasterRCNN. So we will do the object detection using FasterRCNN for the same image. So select the option FasterRCNN and now click on upload. So here we got the detection. We can observe that a person is detected and a green color bounding box is drawn around him and given the label as person. So now we will try using one more image. Click on detection. Click on choose file. So now we will upload this image, third image. Click on open. We'll choose the model YoloV7 and now upload it. Here we can observe that there are multiple aeroplanes detected and one car is detected, and aeroplanes are detected with the blue color bounding box drawn around the aeroplane and with 0.36 for one aeroplane and for other aeroplane 0.39. Similarly for other two aeroplanes also. And here we can observe that car is detected with the pink color bounding box. So now we will do the object detection using the YoloV8 model get back. So for the same image, we will select the YoloV8 for object detection. Here we can observe that YoloV8 has detected the object aeroplane and drawn a bounding box around it. It has detected two aeroplanes and given the probability score, that is detection score, as 0.91. We can observe that more than YoloV7, we have detection score more for this YoloV8. That means that YoloV8 is accurately detecting. Get back. Now we will try using FasterRCNN. Here we got the detection. Here we can observe that there are multiple aeroplanes detected and one toilet is detected. Now we will upload some more images. Click on detection. So now we will be choosing this image. Click on open. Image is loaded. We will choose the model YoloV7 first and now upload it. So here we can observe that there are multiple objects detected from the image. We can observe that a train is detected, car is detected, bus is detected, persons are detected, and here 3 cars are detected. For the same image, we will try using YoloV8. Click on YoloV8 and now upload it. We can observe that a train is detected with the purple color bounding box with the 0.85 detection score. And here we can observe a bus is detected with the green color bounding box with the 0.37 probability score, and multiple cars are detected and one person is detected. We will try for the same image using FasterRCNN. So select FasterRCNN. Here we got the detection and we can observe that there are multiple objects detected. Now we will upload one more image. Click on detection and now click on choose file. So now we will be uploading this image. Click on open and now upload it. So here we got the object detection using YoloV7 algorithm. We can observe that there are 2 cows detected and with their detection scores. Now we will detect objects using YoloV8 for the same image. Here we can observe that there are 3 cows detected. So this YoloV8 is accurately detecting than the YoloV7. In YoloV7 only these 2 cows were detected. Coming to YoloV7, V8, V8 has detected all the 3 cows. And it has highest detection score. We can observe that for the first cow we have 0.96 detection score, and for the next 2 cows we have 0.94 detection score. Now get back. We will try using FasterRCNN. Click on upload. Here we got the detection. This FasterRCNN model has detected the first 2 cows and it did not detect the last cow. So we will upload some more images. Click on detection. Click on choose file to upload some more images. So now we will be uploading this image. Click on open. Select the YoloV7 model first and now upload it. Here we got the detection. We can observe that there are multiple objects detected. We can observe one bus is detected, multiple persons are detected, and one bicycle is detected. So now we will try detection using YoloV8 model. So select YoloV8 for the same image. Here we can observe a bicycle is detected with the blue color bounding box and persons are detected with the red color bounding box. Get back. Now we will do object detection using FasterRCNN for the same image. So here we have multiple detections from the uploaded image by the FasterRCNN model. This is the original picture which we have uploaded, and here we have the detection results from the uploaded image. We will upload one more image. Click on detection. Click on choose file. So now we will be uploading this image. Click on open. Select the YoloV7 and now upload it. Here we can observe that there are 2 motorbikes detected and one potted plant detected. We will try with the YoloV8. Select YoloV8. Here we can observe that there are 2 motorbikes detected with the 0.91 detection score and 0.87 detection score. Get back. Now we'll try with FasterRCNN. Here we got the detection. Here we can observe that there are 2 motorcycles detected and this is the original picture of it. This is the detection by the FasterRCNN model. Now click on detection. As of now, we have uploaded images from our local folder. Now we will try uploading images from the Google. For that, open the new tab first. So open the new tab. We will search for images related to cat. So I'm typing cat. Let's save this image. I'm saving it. Get back to the application. Click on choose file. We have saved this image. Click on open. It is not in the JPEG format, so we need to upload only JPEG format files. So we will search for some more images. So let's try using this image, whether it is JPEG format or not. Let's see first. It is not in the JPEG format. Close it. Let's try for this image. It is in JPEG format, so we will save it. Get back to the application, click on choose file. We have downloaded this image, so click on open and now upload it. So YoloV7 has not detected the object. Let's try using YoloV8 model. Select YoloV8 and now click on upload. Here we can observe that YoloV8 has detected the cat and drawn a bounding box around it with the 0.94 detection score. It is 94% accurate. We will try using FasterRCNN for the same cat image. And here we got the detection. So this FasterRCNN has detected the cat and drawn a green color bounding box. This is the original picture and this is the detected object from the picture. Let's try uploading some more images. Click on detection. We will search for the other images. So we will search for images related to vehicles on road. So let's try this image. Save this. Get back to the application. Click on choose file. So we have saved this image. It is not in the JPG format. So we will try for this image. It is also not in the JPG format. Let's try for this image. It is in the JPG format. Get back to the application. Click on choose file. So we have saved this image. Click on open. And let's use the model YoloV7 and now upload it. So here we got the detection. So there are multiple cars detected and a person is detected from the car. Here we can observe that multiple cars are detected with the pink color bounding box along with their detection scores. Let's try using YoloV8 model. So here we can observe that there are multiple objects detected and here we can observe that multiple cars are detected and one train is detected. We'll try with the FasterRCNN now. Click on FasterRCNN, upload it. And here we got the detection. There are multiple objects detected by the FasterRCNN model. This is the original picture and here we have the detected objects. We will try using some more images. Get back to the Google. Let's try for persons riding a bicycle. Let's save this image. This is not in the JPG format. Let's try this image. This is also not in JPG. Let's try this. It is in JPG. Save it. Get back to the application. Click on choose file. So we have saved this image. Open it and now upload it. So here we have the detection by the YoloV7 model. Here we can observe that there are multiple objects detected. One bicycle is detected. Two persons are detected. One motorbike is detected. Let's try using YoloV8 model. So select YoloV8 and now click on upload. Here also YoloV8 has detected three objects. One is bicycle, two persons. We can observe persons are detected with the red color bounding box and bicycle with the purple color bounding box. Now get back. In this way, just by uploading images to the system and selecting the model, that is whether YoloV7, YoloV8 or FasterRCNN, we will get the detection from the uploaded image. We'll get the objects detected from the image by the individual models. Now click on Sign Out. We have conducted a comparative analysis of three object detection models that are FasterRCNN, YoloV7, and YoloV8, and we have assessed their accuracy, speed, and computational efficiency, found underscored the importance of considering application specific needs when selecting a suitable model, offering valuable insights for researchers and practitioners in the field of computer vision. So, among all the models, we observed that YoloV8 has detected accurately and with the high detection score.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.